Good morning students. Today topic differentiability. This is similar of the continuity. This is given here definition of the differentiability here. Let fx be a real value function. Any real value function we are finding the differentiability here. Defined on an open interval. Open interval. This is symbol of the open interval. This is a symbol of open interval, and this symbol is the closed interval. We are using this as the open interval. This is the open interval, and let C point means I am taking the C points here that belongs to C. Means the C points here belong to AB. Then fx have to be differentiable. Means this function, those function I am taking fx. Means f dash c. So let I am taking here f dash c equal this value here fx minus fc upon x minus c is said to be differentiable or derivable at x equal to c. Means this is differentiable at according to definition this formula of the differentiable, and provided where their point C exists. Those points I am taking here, C point I am taking here, this C point will be exist here. Existing condition same that is continuity condition here. Means left hand limit equal to right hand limit. This is the continuity process. But here we will say here left hand derivative equal to right hand derivative. So now look here, means left hand derivative equal to right hand derivative. If this condition is satisfied means C point is exist. Suppose this condition is satisfied means this point is exist for this real value function. So how to find the left hand derivative? Left hand derivative formula of this limit x tend to c point from left hand derivative means minus sign dependent left hand derivative. Function here same, this function using fx minus fc upon x minus c. Now we can here use limit x tend to 0. This x converted s tend to 0, f c minus h minus fc upon c minus h minus c. What value are left? Limit s tend to 0, f c minus h minus fc upon this c will be cancelled here, so minus hl left. So this is the identity of the left hand derivative. We are finding the value of left hand derivative here, and similarly right hand derivative. Limit s tend to c plus. Positive sign represent here right hand derivative, and function is same that fx minus fc upon x minus c. Similarly f s tend to 0, this will be converting c plus h minus fc upon c plus h, and x plus c plus h minus c. This minus c will cancel here. What is left? Limit s tend to 0, f c plus h minus fc upon h. So this is the identity of right hand derivative. This identity of 4, we will check the value here, then finding the right hand derivative, and here putting the value, then find the left hand derivative. So this is the left hand derivative, this is the right hand derivative. So you will check in this point if this point is exist or not in this differentiable function or not. The next, so you very simple things here. Then the new topic here, meaning of the differentiability at a point. Means how to find the differentiability at a point here. Now look here. Suppose any real value function here, this is the real value coordinates here first, and this is the real value function. I am taking this point. Suppose I am taking this point here, C point. This on point here, C. This is the point P. Value of C here, C, or value of the function f c. Y equal to fx. Means अगर C point है, then using a C. And next, as tend to here 0, means very minor difference left hand side and very minor differences right hand side. Point of the P means del 0, as tend to 0 means very minor difference, nearest of the 0. Suppose you are using the minor difference here, difference between minor difference. Suppose I am taking this point, B point. The name of this one, this is the right side of this, then you can say here C plus H, minor difference. So here position of the point C plus H and value of the function C plus H. Similarly, minor difference of this is the point A, then you can say here C minus H. So C minus H and value of the function C minus H. You can say in this point, left hand side is point A, right hand side point of the B. But this point we can draw a chord. This point and this point. So this is the means you can draw a tangent in this point. This is the tangent of this point. P point is the tangent of the curve this. Then how to find this point, the slope of is equal or not? Then you will find the slope of the AP and slope of the BP here. So now start. Slope of chord AP, y2 minus y1 and x2 minus y1. Same identity here. Limit, what limit है? S tend to 0. C minus h upon fc upon C minus h upon C. What is left here? Limit s tend to 0. Fc minus h minus fc upon this will be cancelled here, minus h. This is the slope of the left hand side. Similarly, find slope of the right hand side here. Now, slope of chord BP, the limit s tend to 0, C plus s minus fc upon C plus s minus C. What is left here? S tend to 0. This will be cancelled here. C plus h minus fc upon h. So this will left hand, slope of the left hand chord equal to slope of the right hand chord, and if both side chord slope is equal, then you can say here this point is differentiable. And so now both point slope is equal, then you can say here the slope of the tangent at point P, which is limiting position of the point of the chord drawn on the left hand side of the point P. Left hand side of the point P is same as the slope of the tangent at point P right hand side. Slope of the point at right hand side, which is limiting position of the chord drawn on the right hand side. Then you can say the point is differentiable and same distance of between this and that. Slope is distance and slope is equal and distance is equal then. But then you can say that this point is differentiable and this not opposite. Yes, student, some important rules here. First rule here, suppose two function u plus minus anyone plus, then you add plus, then minus, and then you divide. Differentiation of two values, two function here, u and p. So this dash sign dependent here, differentiation. That means u and v both having the separate differentiate. Suppose in product form, they are using the identity of the product identity. First and second function, the differentiation of first function multiply second function plus first function differentiation of second function. Dash means dy dv over dx, b dash या d u dash means हो जाएगा dv over dx या du over dx. This is the main differentiation form. And upon here product form, this is the quotient form here, means u upon v. So differentiation of numerator multiply denominator minus numerator and differentiation of denominator and square of the denominators here. So this is the quotient form. In last in chain rules here, this means suppose any two function values here, suppose 2 and 3 and 4, then you find according this chain rules. This is not limit 2, this is 3, 4, 5, 6, this is not matter, but you usually add a chain rules. Then others important identity I will send in the URL portal. Other important identity I will send in URL portal. So these are important rules here. So then other identity I will send you URL portal. Next. And next I am taking the exercise 5.2 question number first and second here. Question: differentiate the function with respect to x. Two function here given, trigonometry function here, and this will be differentiated with respect to x. Now solve first question here. This is the first question. Solution start. This first. Let y equal. This is I am putting this let y equal sine x square plus 5. Now differentiate it. Differentiate with respect to x. In this way, in this x will be differentiate here. So now dy over dx equal to d over dx sine x square plus 5. Now differentiate here. First, identity here sine x, d over dx equal to sine x. Look at cos x and d over dx cos x equal to minus sine x. I mean this is the identity of differential identity of the sine x and cos x. I will send all identity in the your homework assignment and URL. Now first sin x equal to, this is the sine, this will make the theta, sin theta sin x, this will be cos x plus 5. Again using the chain rule here, d over dx x square plus 5 using chain rule. What will you come here? Cos x square plus 5 and again is d over dx x exponent and equal to the n x power n minus 1. So then similarly here this using here 2x 2 minus 1 and differentiate your d over dx. Differentiate your any constant number 5, 10, this will be 0. Differentiate any constant number is 0, this is your 0. So now multiply here 2x cos x square plus 5. This is your answer. Differentiate of the constant number is 0. Differentiate over x square, so 2x to 2 minus 1 according this rule. I am solving this, and according to the constant number here, differentiate of constant number always 0. According this identity I am using here, and this is your answer. Now question number second. Question number second, first is completed. Question number second, the solution of question number second is the let same y equal cos sin x. Differentiate with respect to x, then dy over dx equal to dy over dx cos sin x. So now first making the what is the differential of the cos x? This is minus sin x. So using this identity minus cos x, so mean minus sin x. This is the theta here. This part using in theta. The cos theta means sin theta. Again differentiate d over dx sin x. Again differentiate this part. But then this is the name of the chain rule. Now double time differentiate. First I am differentiating the cos x, the minus sin x. Again differentiate this sin x. This here. This is a double time differentiation. This is using the chain rule. We are using here chain rule. The mention here. So means sin x, the minus sin x. What is sin x here? Differentiate sin x is cos x. This is your answer. So very simple. You learn the identity. This is not problem. If you learn this identity, then not problem to solving these questions. Next question I am taking the question number 4. Same question, differentiate with respect to x. Question number 4. This important questions here. So now start the question here, solution part. So let y equal, this is a function y equal to sec tan root x and double. So now same differentiate with respect to x. Always this question we are differentiating with respect to x. First here dy over dx. So d over dx sec tan root x. First, what identity of this sec? D over dx sec x. This is sec x tan x. Identity of again d over dx tan x. This is equal to sec square x. Here using the two identity here, differentiate of the sec x, the sec x tan x, or differentiate of the tan x, the sec square x. A third identity we will be using here d over dx x exponent n is n x power n minus 1. So in these three identity I am using here. First sec, you make this theta. Sec x means sec theta. That means sec theta means tan theta, sec theta tan theta. The sec theta and tan theta. Again d over dx, this portion tan root x. Means this is we are using the chain rule. This portion is the same. Sec theta means differentiate of sec theta. Differentiate of sec theta means sec theta tan theta. So here I am making sec theta and tan theta. This is the same here. Sec and tan next. Again differentiate it. Tan theta here. So then the differentiate of the tan theta means sec square theta. So again using here sec square theta, sec square theta. Again using the differentiate of this d over dx x to the power 1 by 2. Again using the chain rule here, this will be sec theta tan, here more 3 or 10, this 10 is not really, tan and sec square root x. What will be x power n means this identity using this 1 by 2 s to the power 1 by 2 minus 1. What will become here? This 1 by 2 come here 1 by 2 and solving this s to the power minus x by 2. The x sec tan root x tan root x and sec square root x. Or this x by 2 means denominator means root x here. This will become 1 upon 2 root x. After solving this portion will become this I am writing here. So this is your answer. This is very simple and calculate and find the answer. Yes student, this question is very important question, question number 9, exercise 5.2. This question very important question, came in the board exam many times here, to prove that the function f given by this function x belong all real number is not differentiable at x equal to 1. You will prove that in this limit this function is not differentiable, Now start the question. First of thing, this function is the modulus function. Possible value of the modulus function is two type, positive and negative. First convert this, then start the solution here. Now function here given fx equal mod x minus 1, means what possible value of here? X minus 1 is positive form if x minus 1 greater than equal to 0 and minus x minus 1 if x minus 1 less than 0. This is the modulus function, possible value of the positive. If greater than 0, this greater than 0 means greater than 0, then positive, and this value of the greater than less than of the 0 means my negative value here. So then two types function here, means this is the LHL limit, this is the RHL limit. Less than means LHL or more than means RHL, using this way. So now first we will check differentiability at x equal to 1. This is the C point here. The 1 is here C point. Now check differentiability of first one, the limit s tend to 0, L for left hand. L for means left hand derivative. LHD, left hand derivative. What is formula? The limit s tend to 0, f c minus h or f minus c upon minus h. Using this identity and solve. That means limit s tend to 0, here limit f, c place here 1 minus h minus f1 upon minus h. So, f1 minus h minus f1 upon h. This is the left hand means using the function of this. What function of this here? The limit s tend to 0. Suppose you are putting the value in this limit here. What function here? Minus, first here minus the 1 minus x. This will convert minus x minus 1 means x 1 minus x. So putting the value of this 1 minus h in x place, 1 minus 1 plus h, and again putting here value. What will you come here? Minus h is the same that here 1 minus 1 plus h. Suppose this value putting in this x. What will you come here? Yes, 1 minus h in this minus h. Again 1 f1 suppose you are putting here f1, 1 minus 1, the answer will become here 0, minus 1 minus 1. This will come here, the limit s tend to 0, this will be cancelled and this also cancelled. Here h upon minus h, this is equal to minus 1. Look here again. This function and this two function here. So this is the left hand derivative. So means less than 0 using this function. We are putting minus x minus 1. I am writing 1 minus x. 1 here, same here. Putting in this place x. This value and calculate and this value. This. Next, we'll find here RHL. Similarly, find the RHL here. Right hand derivative of 1. The limit s tend to 0 f1 plus h minus f1 upon positive h. Similarly here, this right hand means more than 0. Right hand means more than 0, the function here x minus 1. X minus 1. So putting this value 1 plus h minus 1. This is again minus 1. Suppose I am putting here 1 minus 1 again. So this plus. What will become here? 1 limit s tend to 0. Here h 1 plus h minus 1 again 1 minus 1. What will become here? Limit s tend to 0. This will be cancelled here. This also cancelled. H upon h. This is come here positive 1. So now it means LHL. So then you are limit this and this using this. This value of the LHL here. Minus 1 here, RHL here plus 1. So this, so L f my differentiate of 1 equal to R differentiate of 1 does not equal. These values does not equal. So then, so you can write here fx is not differentiable at x equal to 1. Means this function is not differentiable at x equal to 1. So this is proved. Hence proved. Hence proved. ये प्रूव आपको ये करना था कि this LHL left hand derivative does not equal to right hand derivative. So according these rules we are solving the left hand derivative, right hand derivative does not equal, means these are not